Hey guys and girls, okay, another long division video. I'm going to go through this fairly quickly. This is dividing large numbers by a two-digit number. So it's going to be pretty much just like the previous long division video I did, except instead of using single-digit numbers that divide into large numbers, you're using double-digit numbers, 10, 21, 14, and 13, as you can see on the screen. You're going to need to rely more on additive multiplication. All multiplication is adding, but for instance with 21, very few people can do the multiples of 21 in their head, or 14 or 13. There's certain numbers where it's easy, like 12 is a good number, but a lot of these you're going to have to go ahead and 21, 42, so on and so forth, either on paper or if you're capable in your head, to get your multiples to divide into these numbers. I'm going to start off with 10 into 790. 790 divided by 10. It ends in 0. 790 ends in 0, so it's a multiple of 10. You can do this one of two ways. One, you can look at it and say, well, 790, 79, that must mean that 79 times 10, because you're going to add that extra 0, because you're adding one place when you multiply by 10. And you can just say 79. Or you can go ahead and do it the way I'm going to do it, just to show you and go through the actions of doing the division. So 10 goes into 79 7 times, and that gives us 10 times 7 equals 70. Do your subtraction, and you're left with 9. Drop your 0 down, just like in the previous video, and you've got 90. 10 goes into 90 9 times, and your answer's there. 10 times 9 is 90. Just to be completely thorough, you don't normally have to do this. I'm just showing you that there's nothing left to divide into. And you're finished with that problem. The next one, 672 divided by 21. This is where it gets a little bit more difficult, because your brain probably can't immediately call up the multiples of 21. So you're going to have to add and add and add. And 21 times itself is 42. You add another 21 to that, so this would be your third iteration, or third 21 that you're grouping together, and you get 63. That's as close as we're going to get. If you add another 21, you're going to go over the 67. So we're going to say 3 times 21. And so 21 goes into 67 3 times. It is 63. So 3 times 21, 63. Your little subtraction problem. You drop your 4 down, and now you've got to take this 2 and move it down next to the 4. Now, from trying to work out how many times 21 goes into 67, you know that 21 goes into 42 twice. Nice and neat like that. 2 times 21 is 42. You've completed that problem. Next one, 707 divided by 14. Once again, do your 14 plus 14 plus 14 plus 14, or if you happen to if you have a calculator, chances are you're not going to be doing it this way, but you could go ahead and plug into a calculator and just keep hitting the add button, I suppose. But 14 does not go into 7, so we have to skip to the next digit, which is 0. 0 is sitting in the tens place of 707. So we're going to have to try to get 14 into 70 as close as we can. And 14 actually goes in there evenly. It goes in there 5 times. 5 times 14 is 70. And you got a 0. Now you've got to deal with this 7. 14 won't go into 7. And if you recall, on the right of every whole number, there's a invisible decimal point and an infinite number of zeros that just keep going. Now, to keep the standard format, I'm going to drop this down. That's no longer there. I'm going to drop down the 7 to our working area underneath the division bracket, and I'm going to put its 0 next to it. Since 14 did not go into 7, I have to put a 0 here. It's a placeholder, sort of. It's a value. It does give value to your answer, but you have to have something here. If I were to, let's get rid of this. If I were to like not have that, and I'd say, well, we know that 14 goes into 75 times, and I put this here, it's wrong. Because then I would be dividing 14 into the 7 and not the 70. So that's not correct. You need to have a 0 right there. And then next to that 0, because there's a decimal point here, you need to put a decimal point. And now you can put your 5 up here. The 5, which represents the number of 14s that fit into this, it's 7.0. But down here, which is our working area, it's just 70. We don't really have to worry about decimal points underneath the problem. The problem is, let's do that. This thing right here is our problem. So anything underneath it, you don't have to worry about moving your decimal points down. It doesn't have to be there. It'll get confusing. Here and here you have to keep your decimal points in order to maintain your places. So there's that. Alright, next problem. 8,827 divided by 13. Oh, those are some big numbers. But if you just go step by step and take it super slow and be precise with your multiplication of your numbers going into your larger numbers, you'll be fine. 13 does not go into 8. 13 will go into 88 6 times. And 6 times 13 is 78. So now we have something interesting that happens. We don't get a single digit down here. 88 minus 78 is 10. 13 won't go into 10 though. So now we've got to just continue. We have to drop this 2 down. Just continue doing that. And now we have to figure out how many times 13 goes into 102. And if you do your math in your head, or however you choose to do it on paper, you'll find out that it goes in there 7 times. 7 times 13 is 91. Bloop. And 102 minus 91 gives us 11. 13 won't go in there. So we've got to take our 7 and move it down here. And figure out how many times 13 now goes into that 117. And it goes in there a precise and lovely 9 times. So there's your answer right here, 679. You could end up, the last video I went into, if we're talking about this problem here, turning a decimal answer into a fractional answer. You take your 50 and you pull it away from your decimal, your 0.5. And the 0.5 is sitting in the tenths place. Just to the right of the decimal is the tenths place. So you take your 0.5 and you just make it a 5 and you throw it over a 10. And then you reduce it because teachers love reduced fractions. So the greatest common factor for 5 over 10 is 5. And 5 goes into itself 1 time, and 5 goes into 10 2 times. So your fractional answer, your rational answer for this problem is 50.5. And there you have it. Slightly more involved, advanced, whatever you want to call it, long division. You can keep doing this with triple-digit numbers. It goes. There's other techniques too. There's like this crazy grid format of division. I don't use that. I learned back in the 80s how to do math, so I've got like the whole ruler across the knuckles if you don't memorize your times tables. Learning in my backpack of knowledge, and that's how I learned. So I don't have any neat tricks like a lot of kids are getting these days, but I do have the basics, and that's what I'm teaching you, and I hope it helps. If you have any questions, comments, complaints, critiques, please feel free to leave them in the comments of this video. I need all the help I can get. I feel kind of, goofy doing this, but alright, thank you. Hope you learned something. Bye.